networks have a variety of connectivity options, ranging from 5G, upcoming 5G, to even satellites, Elon Musk's project. So the attack surface is expanding everywhere. So the concept of self-healing networks comes with the assistance from the machine learning models. So basically, these models helps to identify normal behavior in the networks, and if something is abnormal, something is changing out of the pattern, it can predict what might be the issue. For example, maybe it's a wireless connectivity problem, maybe it's some network bottleneck happening somewhere. So the goal is to be able to identify this early in the process without it having impacting, or at least impacting many users. And it helps to reconfigure the network relevant devices so the network can heal itself. That's why we call self-healing networks. This is a very critical, let's say, functionality of modern SD-WAN networks as well. Software-defined wide area networks, they can select the best path all the time. They can fail over if the problematic, let's say, line comes back and so on. So this all happens automatically without a manual user intervention. This is the concept of self-healing networks. For self-defending networks, it's a journey with Fortinet. As with the self-healing networks, we are moving towards it with many investments, many enhancements on many different technologies we provide under the Fabric concept. So self-defending networks again requires different set of machine learning and deep learning algorithms. That means these algorithms are used to identify anomalous behavior again in network traffic, this time looking for malicious behavior or maybe unauthorized activity or maybe data exfiltration, those kind of things. It looks for user and device behavior, so you then be able to create risk-based scoring, so you can track the behavior of these devices and users. It helps you to identify different variants of malware. It helps you to identify the malware sample that you never seen before through sandboxing, through static analysis, decoding the malware capabilities and so on. And also we are now utilizing natural language processing models like ChatGPT in our technologies, so the administrators of these tools can natively speak, ask questions and get reports, answers, replies back, or it can ask to create some certain configuration for itself. So we are trying to also ease the communication between the human and machines through technologies we have. So it's not perfect, it's not a silver bullet today, the machine learning algorithms. It can create sometimes false positives. The important thing is to get as much as data, relevant data from the sensors you deploy. We are lucky on that regards because more than half of the next generation firewalls shipped today in the world is Fortinet devices. So we have a very large set of sensors, and we also apply multiple different machine learning models on this set of data to look for difference from a different set of eyes. For example, the machine learning for sandboxing is different from machine learning for web application firewall and so on. So the goal is to unify them like we do in our brains, in the body, analyze, process them, and provide actionable threat intelligence throughout the whole ecosystem. It's a long journey. We are moving there, and we need the best interaction between the human expertise and machines today to combat against the evolving cyber threats.